This is a tutorial of the trace properties of the UniMocXChart control. I've drawn two UniMocXChart controls here on this PowerPoint slide so that we can make changes to one and we can compare it to the other. The default values for the chart control is to show the EKG, aortic pressure, pulmonary artery pressure, central venous pressure, and the left atrial pressure. Obviously, we can set whether or not a label is shown, what that label is, whether or not the extrema values are shown, and whether or not the average value is shown. We can also set the color of the trace and the label. So let's go in and make some changes here. We'll stop our slideshow. Right click on the control we want to make changes to and choose the property menu. Go to that first trace that's showing the electrocardiogram. The enable checkbox is obvious and straightforward, but let's go ahead and uncheck it, and you'll see that the EKG is still showing on the bottom chart, but no longer showing on the top chart. Go back into the properties again. Let's re-enable that trace. Now the trace source is essentially, obviously, what you are trying to chart. Patient is sort of a grab bag of a number of different values that the simulation computes that don't associate itself with any individual component of the circulatory system. So in this case, we're showing the EKG for the patient. Let's change that to, say, the tricuspid valve. So now the component of the simulation that we're focusing on is the tricuspid valve, and the property of that component, let's choose the current blood flow. So now we're going to see the flow through the tricuspid valve. By choosing these, we got a suggested label. 4 letters is probably a little bit too long for this very short control, so let's go ahead and shorten that to TQ. Let's show now the average and extremum values for that particular tricuspid valve blood flow. We expect that we have a perfect valve, so we probably don't need to show a minus value, but let's go ahead and leave these settings the way they are right now and just see how our chart looks. So we choose OK and start showing our slideshow. So you can see that we are now showing the tricuspid valve flow, new label. We have a label instead of not having one that we have on the EKG. The label shows up when you choose to show either the extremum or the average value. That's when the label shows up. Otherwise, the label isn't there. Now you note that our range of flow is from 0 to 10 liters per minute. That's the minimum and maximum values of these flows. So to show the full range of our chart here of this particular trace, we're going to need to change our minimum and maximum values of that trace. So let's stop the show and go in and make those changes. So instead of from minus 1.5 to 1.5, let's make this from minus 0.5, so we have a little space at the bottom, and we'll go to, say, 11 liters per minute. Let's also change the color. So let's change the color of the trace to green. Now note, when we make a change to either the trace color or the label color, we're actually making the same change to both. That's because of this little checkbox here. If we uncheck that checkbox, we can change those colors independently. Alright, so let's go ahead and make the label color, let's make it a light blue now. Let's make it a dark blue. There we go, royal blue. Okay, so let's go in and take a look at it, at our charts now. And you can see that we're getting a full range of the chart for the tricuspid valve flow. And you can see that we now have changed our colors from green for the trace and blue for the label. everything is still the same as it was for our original trace chart, excuse me. Okay, let's stop the show, go back into the properties. Now, if you set the minimum and maximum values of a chart, of a trace, you will allow it to auto-scale that trace. So let's say we set it from 1 to 1. Now, what those numbers mean is that it is going to try to fill a certain portion of that particular trace's area, available area, with the trace. 1 to 1 means it's going to try to fill all of the trace area. 2 to 1 means it's going to try to, 2 to 2 is going to try to fill half of that space. So it's 1 over whatever this value is that it's trying to fill with that particular trace. So we'll make it 1 to 1, and we'll go back in and show our charts, and you'll see that we are now just barely clipping at the top of that particular trace. It's filling up all of the available area for that trace. So we'll stop our show and we'll go in and make this something large, say 10. So now only 10%, 1 over 10, 10% of the area will be filled with that particular trace. And so there you have it. Alright, so let's go back in there and set that to, say, 1.5 to 1.5. So 1 over 1.5 of the trace area will actually be filled with that trace. So let's now go into trace 2. Right now it's showing the aortic pressure. Let's make a change to that. Instead of the aorta, let's focus on the pulmonary valve. Okay, so if we choose the blood flow through the pulmonary valve, trace 1 is going to be showing the tricuspid valve flow. The pulmonary valve flow will be shown on trace 2. And let's do the same thing with the minimum and maximum values. And let's change our label, our suggested label now to PQ. And we'll go ahead and keep it red. Okay, so let's go in and take a look at our flows through the tricuspid valve and the pulmonary valve. And you can see that during diastole, we get flow through the tricuspid valve. During systole, we get flow through the pulmonary valve, basically offset. Now, if you want a little bit better view of that, it'll be good to be able to actually overlay this trace with this trace so you can see the relationship between those two traces. So we'll stop our show, go into the properties, go to trace 2 and say we're going to overlap that. Okay, so now we're going to be overlapping the pulmonary flow with the trace before it, which is trace 1. Overlap selected for trace 1 would be meaningless because there is nothing that it can overlap. So only trace 2 through 6 can be overlapped. If you click overlap, we'll show what that does. Obviously, we're doing what we expected. We are now overlapping pulmonary with the tricuspid valve flow. Note that the label is still for the tricuspid valve flow. So the only label that will be shown will be the trace that is overlapped. So if you overlap the very first trace, since it has nothing to overlap, it won't actually overlap anything, but the label will also not be shown because it is an overlapped trace. So that shows us that relationship there. Alright, so let's go in and make one more change here. Trace 3, let's go ahead and continue our theme, and let's show the mitral valve flow for trace 3. And for trace 4, let's show the aortic valve flow, and let's overlap it. Change our suggested label. Let's do one more thing. Let's turn off the 5th trace. That used to be the left atrial pressure. So let's turn that off. And so now we're showing just the flows through the valves of the heart. And so again, during diastole, we are showing the trace for the mitral, the tricuspid valve and the mitral valve. And during systole, we're showing the trace through the pulmonary valve and the aortic valve. Now, let's go in and make a change to the general properties, and we'll speed our chart up, or double the speed. So it's 4 pixels per sample. And this will give us a little bit more detailed view by spreading our chart out a little bit. And we'll show you an interesting property of the simulation and actually of blood flow in the circulatory system of a human. You'll note that at the beginning of diastole, end of systole, we're getting a fairly significant flow both ways through both valves, which means you're getting flow directly from the atrium, right atrium, to the pulmonary artery during this particular period. This is not true on the left side. For the mitral valve flow and the aortic valve flow, this overlap where there's flow through both is essentially insignificant. So during this particular period, we're actually getting flow without actually having any heartbeat, any contraction of the ventricle. Another interesting feature of these particular charts is at the very end of diastole, at the very beginning of systole, you're getting this pulse right here. This is our atrial kick. This is where the atrium begins to, or precedes the ventricle contraction. Contraction of the atria precedes the contraction of the ventricles, and so you're getting this atrial kick of flow through the mitral and tricuspid valves. So that's how you make changes in the UniMocXChart controlled trace properties.